Okay, continuing with study guide. What is electromagnetic induction? So this is where we remember we looked at this simulation where we have the light bulb, and then we have the coil. We moved a magnet in and out of the coil, and we found that if we had a moving or changing magnetic field, we could induce a current. Okay, so that is the basic principle of electromagnetic induction. We've got a changing magnetic field, and it induces a current or causes a current to form. So what happens when a conductor is placed in a changing magnetic field? So let's say we've got a moving magnet, so we can use this drawing as an example. So this would be a conductor, like a current carrying wire, and when we move this magnet in and out of the wire, it's going to cause the electrons to start to move, and a current will start to flow. What factors can affect the strength of electromagnetic induction? So this is similar to what we talked about up here with factors affecting the strength of an electromagnet. So things that affect the strength of electromagnetic induction or are like the strength of the magnet. How fast the magnet is moving. If you move it faster, you'll have more electromagnetic induction. And that's because it goes back to this changing magnetic field. You've got to have a changing magnetic field. So changing magnetic field. Again, your number of coils or turns will impact the strength of electromagnetic induction. If those go up, then you have more induced current. So those are the main items that will affect the strength of electromagnetic induction. And then we talked about some ways that electromagnetic induction is used out in the world. Okay, so we talked about motors, we talked about generators. Both motors and generators use electromagnetic induction. So they both use magnet combined with current. With a motor, you have electrical energy input. So maybe you've got a battery, maybe you're plugging something into a wall socket, and you get a mechanical energy out or motion. So like a fan, as I've told my classes, a fan is a good example of a motor. You plug it into the wall and then it causes the fan blades to spin, so you get a motion there. And then a generator is kind of, to some extent, an opposite of a motor. Here we've got a mechanical energy in. So maybe you're turning something. We looked at like a hand crank radio in my class where you could turn it and it would turn on a light and make the radio play. So you get an electrical energy out. And generators are how like big power is formed. So you could get like a windmill, for example, could be an example of a generator because you've got a mechanical motion from the windmill blades turning, and then that can get converted to electrical energy. Both of these use electromagnetic induction, just in different ways. Okay, but they both use these same principles of a changing magnetic field that induces a current. Okay, let's see. We've got a few questions on the back, and these have to do with the household cost and power. And I think I'm going to save those for the final video.